Hello, everyone, and welcome to today's teleconference on the technology demonstration payloads flying on NASA's Artemis 1 mission. I'm Rachel Kraft with NASA's Office of Communications. Artemis 1 will be an uncrewed flight test that will provide a foundation for human exploration in deep space and demonstrate our commitment and capability to extend human presence to the Moon and eventually Mars. The agency is rolling out the Space Launch System rocket and Orion spacecraft to the launch pad later today and is currently targeting no earlier than Monday, August 29th for launch. Today, you'll hear from people involved in technology demonstrations flying as secondary payloads during the mission. 3 of the demonstrations we'll discuss today are small satellites called Cubesats that will ride to space inside an adapter ring on the rocket and be deployed after the Orion spacecraft is flying on its own toward the Moon. While they each come with risk to their own individual missions, they yield high potential to fill gaps in our knowledge of the solar system. 2 additional payloads we'll discuss involve technology demonstrations that will fly inside the Orion crew module. We have several experts lined up to talk to you today about these investigations. They are Pat Troutman, Strategy and Architecture's Liaison for NASA's Moon to Mars Architecture Development Office at NASA headquarters in Washington. Dustin Gohmert, Orion Crew Survival Systems Project Manager at NASA's Johnson Space Center in Houston. Dustin will discuss the spacesuit worn by Commander Munikin Campos. Raffaele Mugnuolo, Program Manager for the CubeSat ArgoMoon with the Italian Space Agency. Rob Chambers, Director of Commercial Civil Space Strategy at Lockheed Martin, who will discuss Callisto. Wesley Faler, Team Lead for the CubeSat Team Miles. Julie Castillo-Rogez, Principal Science Investigator for the CubeSat NEA Scout with NASA's JPL. And Les Johnson, Principal Technology Investigator, also for NEA Scout, with NASA's Marshall Space Flight Center in Huntsville, Alabama. We'll have a few opening comments from each of these speakers, and then we'll take questions from reporters on the phone line. Reporters can enter *1 on your phone to be entered into the question queue at any time. And with that, we'll first hear from Pat Troutman. Pat?
Rachel, thank you very much. I'm super excited to be here today because with Artemis 1, we begin this new chapter in human exploration of the Moon and Mars. As mentioned, Artemis 1 is primary mission is to validate the envelope of performance for the crew transportation system that will serve as our workhouse for both the crewed lunar and Mars missions. But these secondary payloads, these science and technology payloads on this mission, they're going to tell us about the environment that humans will travel through, and they're going to push that envelope with respect to what advanced technology can do for us on these future missions. So these payloads will inform us how to better protect the crew from deep space radiation, demonstrate advanced propulsion capabilities that enable us to more efficiently send probes and humans to deep space. They'll demonstrate autonomy and inspection technologies that will help future Mars crews inspect their spaceships without having to leave the safety of the pressurized cabin. Now, the added value of these technology payloads brings to Artemis 1 core missions come with some risk of meeting all their mission objectives. They're not subject to the same level of overhead and integration as the primary mission, and that allows them to be more affordable, developed by a diverse set of participants. You know, we have universities, we have companies, we have international partners, and even NASA teams all working together to do these technology demonstrations. And this also allows them to infuse a more cutting-edge technology to take more risk. So, you know, tune in. This is going to be super exciting. It's an incredible beginning to the continuing series of missions that are pushing the envelope and expanding humanity's reach into the solar system. So as a space architect, I look at all these things coming together and meeting our needs now and identifying what we can do better in the future. So with that, the opening statement, I'm going to hand it off to Dustin, who's going to tell us a little bit more about Munikin.
Hey, good afternoon, everyone. So we're here at JSC. We're pretty excited right now for the launch of the Orion Artemis 1 mission. As you know, this is going to be our first mission as we plan to return for a permanent human presence on the Moon and one day beyond. You know, the interesting thing to prepare ourselves for this mission, we have a pretty unique payload on board. We're going to be launching a suit, the Orion Crew Survival Suit, on a suited mannequin. That's Commander Munikin Campos. And the goal is to simulate, test, evaluate the human experience of launch and landing. So Artemis 1 is uncrewed, but with the mannequin, we'll be able to evaluate how that human behaves on the vehicle. This spacesuit that we have, the Orion Crew Survival Suit, or OCSS, or OX, if you even want to go shorter than that, will be worn by all the future astronauts from Artemis 2 and beyond on all the subsequent missions. The function of this suit is pretty interesting. You can almost think of it as a personalized spacecraft, a secondary but much more personalized spacecraft that protects the crew member, provides them pressure, oxygen, cooling, and any other life-sustaining functions that are needed. The novel aspect of this suit versus any suits we've flown before is that it's designed to sustain a crew member for up to 6 days in the event of a contingency. That's a feat we've never before attempted in the history of spacesuits. I mentioned earlier Commander Munikin Campos. So the mannequin on board, named after the legendary Apollo engineer Arturo Campos, he will be riding aboard in this suit on board Orion in a fully flight-like seat. It's designed with advanced occupant safety features that we've incorporated through really the last decade of study. And we've done that to maximize human safety. The NASA Crew Survival Engineering team, that's our team that runs the OX program, we've spent this last decade working to create a fully integrated crew safety system. And to do that, we had to combine the vehicle, the suit, the seat, and the human all into one protective package. With this mission, we're going to measure some of the important aspects of those launch safety features. And with the mannequin, we'll be able to look at the dynamic responses of that system. Well, this is important because it allows us to take what we've learned from testing and from modeling and validate that against the real-world performance so that we can ensure the safety of all the future astronauts. With that, I'll hand it over to Raffaele.
Thank you. This is Raffaele Mugnuolo from Italian Space Agency. I will talk about ArgoMoon Cubesat on board of this important mission, which is, as I told before, the 2 chapters for the Moon and Mars exploration, and we are proud to be part of this important milestone. ArgoMoon is a 6-unit CubeSat able to perform autonomous navigation, target tracking, and target recognition using a very complex image recognition algorithm based on shot photographs. So the first part of the demonstration will be as soon as the CubeSat is deployed. The first part will be the most important one, which will be aimed to take pictures of the interim cryogenic propulsion stage. After that, the CubeSat will be able to maneuver and to put in a safe distance and to perform the second part of the mission, which is the flyby of the Moon, taking a picture of the Moon's surface, as well as taking picture of Earth. ArgoMoon is designed to survive in deep space up to 5 years and is equipped with a payload and which are the 2 cameras. One is the wide angle and one is narrow angle to perform pictures at high resolution. Then ArgoMoon is equipped with a rangefinder, which is a laser rangefinder that is able to measure the relative distance at up to 5,000 meters with a resolution of 0.1 meters. The complete configuration of ArgoMoon includes also the onboard a computer and data handling system, the imaging recognition software, altitude determination control system, and the telemetry and telecommand and electric power system. All the mission will be controlled by a ground mission control center located in Turin at the Argotech site. Argotech is the company which developed the ArgoMoon satellite as a contract with the Italian Space Agency, and this will be the first European satellite control center connected to both International Space Station and to NASA Deep Space Network. Now I hand over to Bob Chambers. Thank you.
Thank you, Raffaele. Good morning or good afternoon, depending on where you are. I'm happy to talk today a little bit about Callisto, which is a 100% industry-funded technology demonstration that will be flying inside the Orion crew module throughout the mission. This is a joint activity by Lockheed Martin, Amazon, and Cisco, who have been fantastic partners. And we're focused on testing out the next generation of crew interface capabilities to see if they would be useful and how they would be useful as we move further out into the solar system for increasing the crew's situational awareness and their efficiency within the spacecraft. We're leveraging commercial technology, which I'll describe in just a moment. And in fact, these commercial technologies that we're extending along with our partners actually provide real benefit to some of the technologies back here on Earth, and I will touch on that. In addition to the industry funding of our efforts, we've also worked with NASA using a reimbursable Space Act agreement. So again, this is 100% commercial industry funded, and we really appreciate the support NASA has given through that reimbursable Space Act agreement. So the objective of this technology demonstration throughout the mission is to look at three things. First, voice control. We are flying a customized version of the Amazon Alexa device. We worked hard, and I'll say that hats off to the engineers at Cisco and Amazon and here at Lockheed Martin. I would walk into the room and not know who worked for whom because of the collaboration. We had to create with Amazon a version of Alexa that could operate on the far side of the moon without connection to the internet, which is how here on Earth the Alexa devices normally operate. But as I noted, these are technology extensions that are useful back here on Earth, and so this is very similar to the hybrid voice control or remote aspects of Alexa where she operates without interfaces back to the internet. So it's a far distance to telecommute from the other side of the moon, but that's what this Alexa voice device will allow us to do. It has access to, they have access to the telemetry stream within Orion, and we'll be able to query state of the spacecraft and status, and also provide some very simplified commands that can control the lights in the cabin, and that's to very controlled so that we have no impact on the mission, but it allows us to test out those command interfaces. And again, the use case for this would be in the future, we're evaluating could astronauts use this to interact with the spacecraft more efficiently and more naturally as we do things here on Earth that can be simplified. The second piece of what we're attempting to test out with this technology demonstration are collaboration tools between mission control and the spacecraft. As the crew moves out further and further into the solar system, of course, there's no crew on Artemis 1, but we can test out tools that could be used in the future. So WebEx by Cisco has provided amazing customized, minor customizations, but as you can guess, there are still some. This is not the stock teleconference or video conference activity to accommodate the delays out to the other side of the moon and all the interfaces to keep them secure that the MCC has with the Deep Space Network, INTEDRIS, and other types of communications interfaces. So there are two aspects to that. One is a WebEx video conference session that we'll be able to conduct. The WebEx software is installed on a commercial tablet that will be in the crew cabin. And via the cameras and our interactions with Alexa, we'll be able to provide a Mission Control Center to spacecraft video conference activity that will allow us to test out that two-way communication. And then the second part of that collaboration set of activities is the WebEx board that allows us to, whenever engineers need to solve a problem, the first thing we do is pick up the pen and the whiteboard and start solving. We will be able to do that on this mission thanks to the Cisco board capability, and we'll be testing out how that could be used in the future when crew is actually on board. And then the third part of the mission testing that we're performing is commercial and high-definition cameras and lights. We had to install those so we could monitor the success of the technology demo. That includes a 360 virtual reality camera that'll give us a inside view of the spacecraft, and I, for one, am looking forward after the mission to see what reentry looked like from the right shoulder of Campos. The reason for those is to evaluate the success of our technology demo, since we don't have anyone on board, but that also makes it super visible for the rest of the country and for the world. So we'll be conducting 2-hour sessions with STEM sessions as we test out the payload and as we test out those technologies. There is a KSC Visitor Center demo planned on August 26th, L-3. So if you'd like more information on how to participate, we'll include some media press time in there. You can reach out to Lockheed Martin and we can give you more information about those. And finally, if you want more information, lockheedmartin.com/Callisto is the landing pad that connects out to Amazon and to Cisco. And of course, you can just ask Alexa to take you to the moon. Don't say fly me to the moon, you'll get the Frank Sinatra song, but take me to the moon, and she'll provide you some background information and updates on the launch all the way up through and the mission during the mission. And you can do that at home. Thank you. And now I'll hand it off to Wes Faler, who's going to talk about the Team Miles mission.
Thanks for a great handoff. Appreciate that. Hi. So Team Miles Cubesat, we're going to deep space about 8 million kilometers from Earth, where our CubeSat will measure deep space weather using student-provided STEM experiments, and will showcase new communication software we invented for extreme-range communication. Now, our spacecraft was built by a volunteer group, actually mostly IT professionals, students, 2 artists, and 1 very patient aerospace engineer. Our craft was built largely from scratch in order to save money, all with the hopes of winning part of NASA's CubeQuest Challenge contest, which is how our craft got onto Artemis in the first place. We'd like to take this opportunity to really thank NASA's CubeQuest Challenge for its great challenge structure and guidance, because we use that to focus our journey into rocket scientists. We don't have the traditional careers that got us here. So with that short introduction and short blurb, I'd like to pass it over now to Julie with NEA Scout. Thank you.
Thank you very much. Hi, everyone. I'm very excited to talk about NEA Scout, the Near-Earth Asteroid Scout CubeSat, the 6U CubeSat that has been developed and funded by the Advanced Exploration Systems. And it's being developed between the Marshall Space Flight Center and the Jet Propulsion Laboratory and other NASA centers. NEA Scout has 2 big components. One is a technology demonstration, and one is about getting very important science information about an asteroid. I will talk about the science, and Les Johnson, my copy, I will talk about the solar sail. So the science is about acquiring observations about the physical and the spin properties of a near-Earth asteroid in order to help prepare for a future crewed mission, but also to understand the hazard that this kind of objects can represent, a hazard to Earth. So there is a planetary defense angle to those science observations. The target is called 2020 GE. It's about 5 to 15 meters across. It's a class of asteroids that has never been explored by a spacecraft before. And it's interesting in that it's in about the same size range as the Chelyabinsk impactor, and over asteroids that are bolids. So these objects, when they crash on the atmosphere, if they are large enough, they can create a lot of light and they can be potentially dangerous to the ground. So the planned observations are both of interest to human exploration, solar system science, and planetary defense. It will take about a 2-year cruise for NEA Scout to get to the asteroid. NEA Scout carries a small camera. It's about half of a CubeSat unit. And the particularity of that camera is that it has been designed to achieve measurements with a quality similar to what's used on big spacecraft missions for solar system science. The solar sail will allow very slow flybys, less than about 20 meters per second. So it will be, even if the asteroid is small, it will be possible to observe it for about 3 hours and to fly below 1 kilometer altitude. So we are expecting a very nice spatial resolution of the ground of about 10 centimeters per pixel. And just to give you a reference, the best images on OSIRIS-REx had a resolution of 5 centimeters per pixel. And I'm going to hand over to Les Johnson now. Thank you.
Thanks, Julie. Yeah, hi, I'm Les Johnson from the NASA Marshall Space Flight Center. I'll be talking about the space propulsion technology demonstration of the Near-Earth Asteroid Scout. We'll be flying a solar sail that is 925 square feet in area. A solar sail, for those that may not be familiar with it, is a type of propulsion system that doesn't use any fuel. Rather, we unfurl a large, lightweight, thin, reflective sail, just like a sail on a sailing ship, only this one looks like aluminum foil, a lot lighter, different material, but it's coated with aluminum to reflect sunlight. And as that light reflects from the sail, it gives up a little bit of its energy in the form of momentum, which pushes on the sail, which will give us the propulsion that we need to take Julie's science instrument to go do the imaging and the science at our asteroid of interest. Now, what's exciting about this 925 square foot sail is that it's thinner than a human hair. It's deployed with 4 metallic booms, each of which are over 20 feet long. And all this is packaged in 1/3 of the NEA Scout spacecraft, and that volume is about 1/3 of a boot box. So it's really tightly packed in there. And this will be the U.S.'s first demonstration and use of a solar sail as a primary propulsion system in deep space. We've had several that have now flown in low Earth orbit as deployment demonstrations and showing that they can obtain some thrust. But for NEA Scout, we aren't just a deployment demo. We've got to deploy, be able to control the sail so that we can reflect the sunlight to navigate and get to this asteroid so the science can be accomplished. The significance of this is that when we've done this, this will open the capability for other small spacecraft to use this type of propulsion, which for small spacecraft gives you more total propulsion than any other system that can be packaged into such a small volume to enable this kind of robotic deep space exploration with small spacecraft. It's not a one-size-fits-all propulsion system, but for some classes of missions, very small ones operating near the sun, it'll be a whole new capability and an exciting one because we just don't run out of fuel, which means we have a lot of mission flexibility and can adjust dynamically as we fly. So that describes the NEA Scout, and look forward to having any questions you have in the future of the call. Thanks.
Okay, thank you. We'll now begin the question and answer portion. As a reminder for reporters who are on, you can enter *1 on your phone to be entered into the question queue at any time. Your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. And we ask that you please stick to one question, and given that we have quite a few speakers on, if you can please identify to whom your question is directed, that will be a big help. And if we have additional time, we'll allow reporters to ask a second question. And so with that, we'll take our first question. I believe we have Stephen Clark from Spaceflight Now.
Hi, thanks for taking my question. I think my question is for the NEA Scout team. I'm sorry if I missed this, but can you walk through sort of the timeline of the mission after you deploy from the Space Launch System? When do you actually unfurl the solar sail? And when do you reach your target asteroid? And I'm curious, given the delays and the intricacies of orbital mechanics, if you've had to change asteroid targets throughout the mission history due to the delays. Thanks.
Yeah, this is Les, and I'll tackle the sail part of that and let Julie talk about the asteroid destinations. We are deployed from Artemis about 3.5 hours into the flight, not the sail. That's when the spacecraft is deployed. And the solar sail won't deploy until several days after that. It could be up to a week to two after that, depending on the actual launch time and where we are in the trajectory. So we're going to just do check out of the spacecraft, make sure that all the systems are functional, the power is working, we can call home, all that good stuff. And then we'll be deploying the sail sometime after the first lunar flyby. So it'll be a week or two into the mission.
For the asteroid, so right now we have a target available for the next few months, and there is a backup target that is going to be observed by the Very Large Telescope sometime this week, just after the full moon stops being above Earth for astronomers. We have an opportunity to recover an NEO that seems very good, very accessible for NEA Scout. But we don't know its position very well, and so with the VLT images, we will be able to know its position. So if there are further delays, launch delays, we are covered. Thanks for the question.
Thank you. Our next question is from Jeff Faust with Space News.
Good afternoon. Question for Wes of Team Miles. Since you had sort of this, this group of non-professionals working on the satellite, I'm curious if there's anything about the mission that you're particularly going to be watching closely after deployment of the spacecraft, any subsystems that you're going to be looking at very closely as you head out to your deep space destination. And do you have any concerns about the battery life on the spacecraft, since I believe you are one of the CubeSats that wasn't able to recharge after you were installed? Thanks.
Wow, great questions. Hello. So we're going to be monitoring very closely the communications response from the craft, because that's really where our commercial future lies, is the success of our novel communication algorithms out there. And that's also how we're going to be able to fulfill our promises to the STEM students to deliver their space weather data. So that has all of our attention. Actually not very worried about the battery charge. We had an opportunity to charge, but we opted out of it. There's such a low discharge, self-discharge rate on our batteries that we figured why rock the boat and introduce the variable of recharging. And so we opted out of that. And our satellite deploys panels autonomously. They're spring-loaded. They come out. So we could technically fly with a completely dead battery, although at this point we probably have about 85% battery aboard the craft anyway, though. Thank you.
Our next question is from Ramin Skiba with Wired.
Hi, this question is for Julie or possibly Les about NEA Scout. I was wondering, how did you select this asteroid target? Like, what particular qualities, make this an interesting target? And how would you, like to see this mission, help prepare for future asteroid missions, like for a crewed one?
So maybe I'll take the first part, and I will let's talk about the second part. So, you know, there are a lot of NEOs that have been discovered, but only a few are really accessible to us because we have a few constraints to meet. And one is the telecom distance at the time of encounter, for example. It has to be less than 1 astronomical unit. The target has to be well-known. Its position has to be well-known. And another constraint is, these are the two main constraints. So even if there are a lot of asteroids, there are only a few that are actually accessible at any given time. And we've been lucky throughout the development of the project to be able to access, to have access to multiple targets. So we don't pick the target picks us, and for within our constraints, there are only objects that are very small, less than 50 meters diameter. Yes, you want to talk about the future of exploration?
Yeah, hi. The only comment I can really give to that is I don't believe there are any current plans to send people to an asteroid, but before you would ever want to do that, I'm sure you'd want to do some kind of robotic reconnaissance to get an idea of what that asteroid looks like, so that you could make sure you could do all the proper preparation for sending people there. And that was one of the reasons for NEA Scout early on, was to basically do science and also be a demonstration of a capability for doing very small spacecraft as a reconnaissance mission.
Thank you. Our next question is from Brett Tingley with Space.com.
Hi, I guess this is primarily a question for Rob Chambers. I'm just wondering, as far as the Callisto payload goes, how or perhaps why is it that the Alexa digital assistant was chosen over any other perhaps candidates for a voice-activated digital assistant?
Yeah, great question. For both of our partners, we looked at what the technologies that were out there, but also at the kind of common mission statements we saw with the companies. And I'll be honest, we picked up the phone and called Amazon, and it was one of those, hey, what do you think about flying an Alexa on the other side of the moon? And I expected to get a very puzzled response, but instead they explained that one of the, and this is their story, but they share it a lot, one of the progenitors for Alexa, one of the thoughts that they had, if you will, was the voice computer from Starship Enterprise. And so in some ways, they said, we've kind of been waiting for this moment in some ways. So as soon as we started talking with them and talked about some of their local here on Earth activities where they have to operate Alexa without the internet, we realized it was a really awesome test case for what they wanted to do. So the response was so strong, and the technologies and the knowledge was so deep, and our kind of commitment to the mission and connectivity was really powerful off the get-go, that we just never looked back.
Thank you. Our next question is from Marvin Marshall with Nighttime News.
Hi, thank you for taking my question today. My name is Marvin Marshall from the Nighttime News Space Report. My question is for Dustin about crew survival on Artemis 2. And now, in case of an emergency and an off-normal situation after reentry with the main and backup chutes, is there possibly a way that the crew is able to remove like the main hatch and then possibly even parachute down safely to Earth in a situation? Thank you.
Hey, good afternoon, and thank you for the question. So you're kind of referring to a similar concept that we had in shuttle, whereas each crew member wore a personal parachute assembly, and there was a high altitude bailout case that we had prepared for that would have allowed the crew to evacuate the capsule starting around 30,000 feet. In Orion, though, we do not have that capability. Instead, what we've done is design the seat and the crew interface to the seat such that it's almost like a race car seat, if you will, that forms a cocoon around the occupant. The seats also sit on shock absorbers that will take out excess energy in the case of a one or even two shootout landing or rough seas landing. And so we really tried to look at the more feasible scenarios, more likely scenarios, and just go to as many lengths as we could to enhance crew survivability. By eliminating the excess bulk that the crew might have on their body from something such as a parachute assembly, it allows us to really tightly integrate the person to the seat with really form-fitting seat belts. And then with that, we've done the testing primarily with mannequins, crash test, anthropometric dummies over the years to ensure that we have a very tight fit. And here in the next few years, we'll actually be doing some human testing with our Air Force partners to really validate that safety response.
Thanks, Dustin. Our next question is from Philip Odojelski with Polish TV.
So, hi, thank you for the opportunity to ask a question. I want to address my question to Dustin. So, are there any differences between the current Orion spacecraft and suits used in the Artemis 1 mission and the future Orion spacecraft and the future suits for the crew Artemis mission? So, have you made any updates to be introduced in the future missions? Thank you.
Surely there will be a few, I'll call cosmetic updates that we will be doing between now and then. We're working on final layouts of things like name tags and patches and color codes for crew identification. But by and large, the design has been finalized as of our critical design review that we held a few years ago. It's so much similar that the suit we're flying on Artemis 1 is the suit that we use to qualify the integrated suit and seat and occupant system for Artemis 2. So the neat thing about its accuracy is that this has already been through a vibration test at Kennedy Space Center that we performed collectively with Lockheed. And this suit, with its accuracy, will then be allowed to give us the very accurate predictions of the suited human response when it comes back, well, both during launch and during return. Overall, though, the similarities are, there's going to be patterning updates that are done for every suit because they will be custom for every person. But by and large, the suit is functionally identical to what we will be flying for the Artemis Mission 2 and beyond.
Thank you. Our next question is from Lisa Grossman with Science News.
Hi, this is a question for Rob, I think, about Alexa on the mission. I'm just curious about how it's going to work when there's not a human on board. There's no one on board to use a voice-activated function. So just how is it actually going to happen? We have a recording saying, Alexa, tell me about what it's like outside in space, or what actually are you going to do in an empty capsule? And will Alexa speak back inside an empty capsule?
Sure, absolutely. That was one of the strong reasons after chatting with Amazon, we then reached out to Cisco, who's the premier leader in connectivity, I would say, because we realized we wanted to have an exercise of the system without the crew on board that would connect us to what we call virtual crew members back in the Mission Control Center in what is called the Ops Suite 5 that we'll be using throughout the mission. So the concept is from Mission Control, testers, you could call them virtual crew members in a way, will ask a question of Alexa via the WebEx system. We'll be able to then observe, because of the cameras and speakers and microphones we have on board, we'll observe that did come out through the speakers in the spacecraft. Alexa will process that audio in the spacecraft in that acoustic environment, which I can tell you I learned more about acoustics than I thought I ever would. It is not designed for acoustics, right? It's a small metal enclosure. So we had to work through all of that. She'll interpret that voice control, and actually by being connected to the telemetry stream in Orion, provide information and data synthesis from the actual spacecraft. So they're not pre-recorded messages, it's not canned things, it's actual real-time processing of the onboard computer data through the telemetry interfaces, and then she'll respond. The key is that all of that smart has to be on the spacecraft, because we didn't want to suffer the time lag of going back up to the spacecraft, back down to Earth, back up and back down again for the Alexa device to connect out to the internet. So her voice processing, everything that happens in the cloud here on Earth is actually embedded on a dedicated spacecraft computer in the spacecraft. So we'll interact with her via the WebEx connectivity, video conference, and she'll respond in real time with real data from the spacecraft to test out the technology end to end.
Thanks, Rob. We'll take another question, this one from James Hillhouse with America Space. James, we have your mic open on our end. If you're there, we can't hear you.
Sorry about that. Mute button accidentally got hit. This is for Rob Chambers, with my apologies. I wanted to follow on a question earlier asked about how Alexa was chosen, and I just want to ask two questions. One, did none of the other companies, were they less enthusiastic? I guess I'm referring directly to Apple. And the second question is, you mentioned a tablet. Who makes that tablet, and was it specially configured to operate within Orion, or were you able to just take it more or less off the shelf?
Yeah, excellent question. So first, everyone we've talked to has been super excited about this. We went with the folks, like I was saying earlier, that we felt really strong connection to, and that it kind of meshed with where they were headed. And so Alexa and the ubiquity of it just made sense to us. The tablet, though, is actually built by Apple. We reached out to them, and they provided some really awesome engineering support. I definitely need to give them kudos there. There's probably two things that you might guess that they had to configure for us, and we're very much appreciate their engineering support. One is the tablet needs to power off when you drop power, so that you can reset it. Of course, we, the human race, have been using tablets in low Earth orbit for a long time. They do suffer upsets, and you just have to power cycle them. So we wanted to be able to shut the system off completely, and also shut it off from a safety perspective during parts of the mission. And so, of course, if you just have a battery inside, it'll eventually shut off, but not for many, many days. So they helped us by being able to not have that battery pick up power. The other thing is they gave us interfaces to the lower level operating system, so that in a way such that when we power up, we have remote control of that system to be able to drive the apps, for example, the WebEx or the WebEx board.
Okay, thank you. We have no other reporters in the question queue, so we'll go ahead and wrap up. I want to thank you all for joining us today, especially our participants. As a reminder, we'll be rolling out the SLS rocket with Orion on top later on today. The target time for that is 9 p.m. Eastern. You can watch that live on the NASA Kennedy Space Center Newsroom YouTube channel. And we will also be hosting another media teleconference at noon Eastern tomorrow to continue talking about some of the payloads flying on this mission. That one tomorrow will be focused on the secondary payloads that are having to do with studying radiation. And you can, of course, find more on the CubeSats, the items flying inside Orion, and the rest of the mission at nasa.gov/Artemis-1. Thank you.